Dear students, it's my observation that many of the students they have the problem with the integration of square trigonometric functions like the integration of sine square, integration of cos square, integration of tan square, integration of cot square, and integration of sec square and cosec square. They commit some mistake. The reasons are many, like they are not using proper trigonometry formula, or they are committing plus and minus, are they confused with whether to divide by 2 or not divide by 2. Such a silly mistakes they perform, and they do total wrong solutions, and they lose the marks in their examinations. So today I thought that why not to prepare a video so that the problem of many of the students will easily solve and they will get their marks in the examination. Of course, the integration of this square trigonometry function plays an important role, because many of the questions, whenever the trigonometry coming, many of the question, the square is troubling to many of the students. Therefore, we have to get rid of this problem. Therefore, the purpose of making this video. So let's start the integration of squared trigonometric functions. Before starting integration, let us revise the formula for the cos 2x. Cos 2x having the two formulae. One is the 2 cos square x minus 1, or 1 minus 2 sin square x. So let us talk about the first formula. Cos 2x equals to 2 cos square x minus 1. So 2 cos square x equals to 1 plus cos 2x, and cos square x equals to 1 plus cos 2x upon 2. So when you are doing integration of cos square function, you must remember this formula. What is that? Cos square x equals to 1 plus cos 2x upon 2. Similarly, the second formula, that is cos 2x equals to 1 minus 2 sin square x. So 2 sin square x equals to 1 minus cos 2x. Therefore, sin square x equals to 1 minus cos 2x upon 2. So we have the second formula, that is sin square x equals to 1 minus cos 2x upon 2. So these are the two important trigonometric formulae you must know whenever you are doing integration of sin square x and cos square x. So please write down these two formulae aside in your notebook, so that while doing you will not confuse. And here the logic is that when the cos square x is there, here is a plus, and when the sin square is there, there is a minus. Remember that logic. But in both the formulae, the other things are same. Here is the 1 and cos 2x upon 2, 1 and cos 2x upon 2. Only difference is there. In case of cos square x, there is a plus here, and in case of the sin square x, there is a minus. Now let us do some integration problem based upon sin square x and cos square x. Now we'll start with integration of cos square x. How to find integration of cos square x with respect to x. So whenever the cos square is there, cos square x equals to what? 1 plus cos 2x upon 2. So in place of cos square x, we can write 1 plus cos 2x upon 2 with respect to x. Remember that directly we cannot do the integration of cos square x. Whenever the cos square x is appearing, you have to convert to trigonometry form, that is cos square x equals to 1 plus cos 2x upon 2. After the converting this, we can do now integration very easily. 1 by 2 is taken outside, integration of 1 plus cos 2x with respect to x, and after that 1 by 2 as it is, integration of 1 is x, and integration of cos 2x is nothing but sin 2x upon 2 plus c. Here is the job is over. I would like to tell you that the integration of sine ax, and integration of cos ax with respect to x. In both cases, integration of sine ax is nothing but minus cos ax upon a, and integration of cos ax with respect to x nothing but sine ax upon a. Therefore, integration of cos 2x is with respect to x, it becomes what? Sine 2x upon 2. So therefore here I have written sine 2x upon 2 plus c. So final answer is x by 2 plus sine 2x upon 4 plus c. This is the integration of whom? Integration of cos square x with respect to x equals to x by 2 plus sine 2x upon 4 plus c. Now I will help you. I will tell you how to do integration of sine square x. Suppose you want to find integration of sine square x, then sine square x with respect to x. So here first of all, same thing here like cos square. There is no direct integration for cos square x. Also there is no direct integration for sine square x. As soon as the sine square x comes, what you have to do? First convert to trigonometry. Apply the trigonometry. Whenever the sine square x there, you directly write down 1 minus cos 2x upon 2 with respect to x. So here sine square x converted to 1 minus cos 2x upon 2, 1 by 2 outside, integration of 1 minus cos 2x with respect to x, and after that 1 by 2 as it is, integration of 1 is x minus as it is, and integration of cos 2x is nothing but sine 2x upon 2 plus c. This is equivalent to x by 2 minus sine 2x upon 4 plus c. This is nothing but integration of sine square x with respect to x equals to x by 2 minus sine 2x upon 4 plus c. Here is the cos square x and sine square x, but always there is no cos square x. Cos square will come with some number like kx. What is k? K is any number. Cos square kx. So the cos square kx can be written as 1 plus cos 2kx upon 2. The formula will get converted like this. Cos square kx equals to 1 plus cos 2kx upon 2. Similarly, sine square kx, that can be written as 1 minus cos 2kx upon 2. So this way the cos square and sine square x can be converted to easy trigonometry form. Here example, here cos square, suppose 10x is there. So what is k value? K value is 10. So cos square 10x equals to 1 plus cos 2k, 2 into 10x upon 2. So that is equals to cos square 10x is equals to 1 plus cos 20x upon 2. Similarly, suppose sine square, you here any number, there is no doubt about whatever the number, suppose 40, sine square 40x is there. This can be written as 1 minus cos 2kx, that is the 2 into 40x upon x, that is equals upon 2, not x, upon 2. So 1 minus cos 80x upon 2. So this way what happened? Sine square 40x is equals to 1 minus cos 80x upon 2. This way whatever the number comes there, you can easily convert into the very simple form. After that you can start doing integration. Let us take one example. Suppose you want to do integration of sine square 5x with respect to x. So first of all convert into the simple form, that is sine square kx nothing but 1 minus cos 2kx upon 2. So k value is the 5 here, 1 minus cos 2 into 5x upon 2 with respect to x. This is equals to 1 minus cos 10x upon 2 with respect to x. So that is I equals to, whenever the integration given, we can write I equals to, therefore I equals to 1 by 2 is taken outside, and integration of 1 minus cos 10x with respect to x equals to 1 by 2. Integration of 1 is x minus, and integration of cos ax with respect to x is nothing but sin ax upon a plus c. Therefore, integration of cos 10x nothing but sin 10x upon 10 plus c. This is equals to x by 2 minus sin 10x upon 20 plus c. This is nothing but integration of sin square 5x with respect to x. Now I will take one more example based upon cos square. Suppose you want to find out integration of cos square. You give me any number, like somebody has given me 7x, no problem. The integration of cos square 7x with respect to x equals to how much? Whatever the number may be there, don't bother about number. I equals to integration, here cos square kx nothing but 1 plus cos 2 kx upon 2. So 1 plus cos 2 k is nothing but 7x upon 2 with respect to x. So I equals to integration of 1 plus cos 14x upon 2 with respect to x. So I equals to 1 by 2 is outside, integration of 1 plus cos 14x with respect to x. This is equals to 1 upon 2, integration of 1 is x, and integration of cos 14x nothing but sin 14x upon 14 plus c. So that is equals to x upon 2 plus sin 14x upon 28 plus c. This is required solution. Now there are the two problems. One is the integration of sin square x by 3 with respect to x. Another question, integration of cos square x by 4 with respect to x. Here the I equals to integration of sin square kx nothing but 1 minus cos 2 kx. So 1 minus cos 2 k value 1 by 3 x upon 2 with respect to x. This is equals to 1 minus cos 2x by 3 upon 2 with respect to x. This is equals to 1 by 2 is outside, integration of 1 minus cos 2x by 3 with respect to x. 1 by 2 as it is, and here is a integration of 1 is x, and integration of sin 2x by 3 nothing but cos 2x by 3 nothing but sin 2x by 3 upon a nothing but 2 by 3 plus c, which can be further simplified as x by 2 minus 3 by 4 sin 2x by 3 plus c. This is the solution of this question. Similarly, cos square x by 4, I equals to, how to do integration? Now this is nothing but 1 plus cos 2x, that is 2 into x by 4 upon 2 with respect to x. 1 by 2 outside, integration of 1 plus, if you can cut them, you can cut. So it is a x by 2, that is a cos x by 2 upon 1 by 2 already we have taken outside with respect to x, that is equals to 1 by 2 integration of 1 plus cos x by 2 with respect to x. Here 1 by 2 integration of 1 is x, and integration of cos is nothing but sin x by 2 upon a, that is 1 by 2 plus c, which is nothing but equals to x by 2 plus 2 upon 2 sin x by 2 plus c. This can cancel. So this way we can do the integration of cos square x upon 4, whatever the number is there, whatever the number, we don't bother about the number, whatever the number we can perform the integration. Now let us do the integration of sec square x with respect to x and integration of cosec square with respect to x. For sec square and cos square, direct formula available. Integration of sec square x with respect to x, nothing but tan x plus c, and integration of cosec square x with respect to x, nothing but minus cot x plus c. Example, integration of sec square kx with respect to x is equals to tan kx upon k plus c. Similarly, integration of cosec square kx with respect to x equals to minus cot kx upon k plus c. Example, integration of sec square phi x with respect to x is equals to tan phi x upon phi plus c. Similarly, integration of cosec square tan x with respect to x equals to minus cot tan x upon 10 plus c, because k equals to 10 here and k was 5 here. So one more example, integration of sec square x by 2 with respect to x equals to tan of x by 2 divided by 1 by 2 plus c, or integration of cosec square x by 3 with respect to x equals to minus cot x by 3 divided by 1 by 3 plus c. This way we can do very easily. The sec square and cosec square are very easy. The direct formula available. Now on the basis of this, let us do the integration of tan square and cot square. Now integration of tan square x with respect to x and integration of cot square x with respect to x. Here there is no direct formula available for tan square and cot square, but first we have to convert into trigonometry, simplify trigonometry, that is 1 plus tan square x equals to sec square x. Therefore tan square x is equals to sec square x minus 1. Therefore integration of tan square x with respect to x equals to integration of sec square x minus 1 with respect to x. This is equals to tan x minus x plus c. Similarly, integration of cot square x with respect to x. First we have to use trigonometry here to simplify, to convert the function. 1 plus cot square x equals to cosec square x. This is the basic identity. From this one, cot square x equals to cosec square x minus 1. Therefore integration of cot square x with respect to x equals to integration of cosec square x minus 1 with respect to x equals to minus cot x minus x plus c. Integration of cosec square x is minus cot x, integration of 1 is x, so minus is there, therefore minus x plus c. Example, suppose find the integration of tan square phi x with respect to x and find the integration of cot square 3x with respect to x. Whatever the number is there, we don't bother about number. Here is a phi, in place of phi any number, 7, 8, 12, 100, 200, whatever it may be. So we don't bother about the number. The logic is the tan square, here the trigonometric identity, tan square phi x equals to sec square phi x minus 1. Therefore integration of tan square 5x with respect to x equals to integration of sec square 5x minus 1 with respect to x. So integration of sec square 5x with respect to x minus integration of 1 dx. Directly also we can write, like previous case I have written directly, you can write directly also. Now sec square 5x with respect to x nothing but tan 5x upon 5 minus x plus c. This is the required solution. Similarly for cot square 3x, cot square 3x is equals to cosec square 3x minus 1. Therefore integration of cot square 3x with respect to x equals to integration of cosec square 3x minus 1 with respect to x, that is equals to minus cot 3x upon 3 minus x plus c. This is what the solution. Next example, integrate with respect to x, integration of 1 upon 1 plus cos 2x with respect to x. First of all, we simplify denominator 1 plus cos 2x. Now cos 2x formula is 2 cos square x minus 1. You have to use the cos 2x formula such that the 1 get cancelled. Now here 1 getting cancelled here. So that is equals to 2 cos square x. Therefore 1 upon 1 plus cos 2x is equals to 1 upon 2 cos square x. Therefore integration of 1 upon 1 plus cos 2x with respect to x equals to integration of 1 upon 2 cos square x with respect to x. Now I equals to 1 by 2 taken outside, and here 1 upon cos square x with respect to x equals to 1 by 2. 1 upon cos square x can be written as sec square x with respect to x. Therefore I equals to 1 upon 2 integration of sec square x nothing but tan x. Therefore it is tan x upon 2 plus c. I equals to tan x upon 2 plus c. This is required solution. Next example, integration of 1 upon 1 minus cos 2x with respect to x. I already told you that whenever the cos 2x is there and 1 is there, you have to use the cos 2x formula such that 1 will get cancelled. So cos 2x is nothing but 1 minus 2 sin square x. Now opening the bracket, 1 get cancelled, equals to 2 sin square x. Therefore integration of 1 upon 1 minus cos 2x with respect to x equals to integration of 1 upon 2 sin square x with respect to x equals to 1 upon 2 outside, integration of 1 upon sin square x with respect to x, that is equals to 1 by 2 outside, and that is nothing but cosec square x, integration of cosec square x with respect to x equals to minus cot x upon 2 plus c. This way we handle. In this way we do the problem whenever the 1 minus cos 2x is there. First we have to cancel the 1 and after that simplify, then after that you do the integration. Next example, evaluate integration of 1 upon sin square x dot cos square x. Solution, I equals to integration of 1 can be written as sin square x plus cos square x. 1 is equivalent to sin square x plus cos square x upon sin square x dot cos square x with respect to x. I equals to, this can be written as sin square x upon sin square x dot cos square x plus cos square x upon sin square x dot cos square x. Here I have utilized formula a plus b upon c equals to a upon c plus b upon c. Here sin square cut, here cos square cut, then I equals to integration of 1 upon cos square x plus 1 upon sin square x with respect to x. This is equals to integration of sec square x plus cosec square x with respect to x. Integration of sec square nothing but tan x, and integration of cosec square x nothing but minus cot x plus c. This is required solution. Next example, evaluate integration of tan x plus cot x whole square with respect to x. So integration of tan x plus cot x whole square with respect to x equals to, we can open the bracket here, tan square x plus cot square x plus 2 tan x into cot x. We have opened the bracket by using formula a plus b whole square equals to a square plus b square plus 2ab. Therefore, I equals to integration of tan square x plus cot square x and tan x into cot x equals to 1. Therefore, 2 into 1 with respect to x. Now, there is no direct formula for tan square and cot square. Therefore, tan square equals to sec square x minus 1 and cot square equals to cosec square x minus 1 plus 2 with respect to x equals to sec square x plus cosec square x minus 2 plus 2 with respect to x plus 2 minus 2 gone. So that is equals to sec square x with respect to x, integration of cosec square x with respect to x, integration of sec square x nothing but tan x, and integration of cosec square x nothing but minus cot x plus c. This is required solution. Next example, integration of cos 2x upon sin square x dot cos square x with respect to x. Here the cos 2x formula we are going to use is cos square x minus sin square x. This is one more formula for cos 2x. Therefore, I equals to here cos square x minus sin square x upon sin square x dot cos square x with respect to x, which can be simplified as cos square x upon sin square x dot cos square x minus sin square x upon sin square x dot cos square x with respect to x. Here cancellation possible, cos square, here sin square cancellation. Therefore, I equals to integration of 1 upon sin square x minus 1 upon cos square x with respect to x. This is equals to integration of cosec square x minus sec square x with respect to x. Here integration of cosec square x nothing but minus cot x, and integration of sec square x nothing but tan x plus c. Therefore, minus cot x minus tan x plus c is the final required solution of given question. So how do you find? You might have found that integration of square trigonometry function is easier than drinking a cup of coffee. Only thing is required little practice and the few formulae. Even these formulae are quite easy, only you have not to commit the mistake of plus and minus. So integration of square trigonometry function is easy. You just keep in your mind. So please give me your feedback. How do you find this video? And also give some comments so that I come to know how is my presentation. Keep on doing the mathematics. I tell you that whenever you want to get the perfection in mathematics, you have to do the problem yourself. I found that many of the students just they read the problems, they read the solutions. It will not going to help you. You cannot become master of mathematics just if you are reading some mathematics. Learning mathematics is nothing but doing them. So if you want to get more and more perfect in mathematics, then take the difficult problems and try to solve them. If you are not getting, keep on thinking. Ask your friend how to do. Learn from the friends. Learn from the teacher. So give me a feedback. How do you find this video? And if you have liked and if you are interested to learn the mathematics, then like the video, subscribe the channel, and share with your friends. Meet you again with another topic of integration. Till then, wish you good luck. All the best.